Dr. Zach Asher from Western Michigan University joins us this evening. Thank you for being here, Dr. Asher.
Yeah, no problem. Happy to be here.
Hey, you've been researching a very interesting topic, which seems to be the way of the future, self-driving cars. What all goes into making a self-driving car work and how to do it safely?
A lot, actually. So there's a ton of expensive sensors that provide redundancy. So there's cameras, radar, LiDAR, GPS, sometimes high definition maps are used. And so if you have all of these different sensors that are potentially detecting the same thing, there's also a lot of development that goes into fusing the signals and then acting upon that information. And so artificial intelligence can sometimes fill in those gaps. And suffice it to say, it's a lot of hard work, a lot of computer processing.
Yeah, it sounds like a lot of data assimilation there. How much does weather play into the reason we aren't seeing more self-driving cars everywhere on the roads today?
Yeah, so weather is a big deal in terms of autonomous vehicle operation and development. Right now, companies and universities are working very hard to implement autonomous vehicles in clear weather, and they're struggling a lot with that, right? There's a Waymo pilot in Arizona. We have a couple of pilots here in Michigan that we do every once in a while, and typically they're restricted to perfectly sunny days, right? And so if we can get that working, then we can show with inclement or adverse weather, the vehicle can also operate there.
Well, that's a good point. I mean, you got to start somewhere, right? So if you're still trying to get the sunny days thing to work, if you look down the road, in your mind, what are some of the more challenging elements of weather scenarios which you might struggle with this?
Yeah, so this is a topic that we think about a lot, actually. I have a couple of PhD students who are working on this right now, and we're working on commercializing some of the technology behind this. But one scenario I could point to specifically is when the lane lines on a road are covered by snow. And so typically with a lot of autonomous vehicle or automated vehicle technologies, there's cameras that are looking to identify the lane lines. And there's no solution for what happens when those lane lines are covered by snow. So that's one of the things that we're looking to try to develop, and it's a really challenging operational scenario.
Yeah, I can imagine. Hey, there's a big push for green energy and being eco-friendly. How efficient are autonomous cars?
It turns out they're not that efficient. All of those sensors that I mentioned can have significant power draw. And additionally, all of the algorithms that fuse those sensor signals, all of the AI algorithms that act upon those sensor signals, those can have a pretty massive power draw as well. And so if you think about all of those power draws adding up, it's pretty straightforward to then calculate the effect on an electric vehicle's range, for example. And so nobody's going to be happy if they bought an electric vehicle that has a limited range, say 250 miles, and all of a sudden that range gets cut by 25% because we have all of these sensors that are running continuously.
What do you think about the net positive impact on the climate these cars may or may not have?
So I think if we can get the energy efficiency improved a little bit, that the use case for autonomous vehicles, and specifically autonomous and electric vehicles, becomes a little bit more palatable. And if we can continue to promote this technology, there will be effects on reducing climate change and help make transportation more sustainable than it currently is.
Okay, I want you to play Nostradamus here. When do you see these types of cars that you're working on becoming the norm, if ever?
So, of course, that's the complicated question to answer. And I might think about it this way, or I might propose my answer this way. So the way that I look at it is it's not all about autonomous vehicles. It's more about automation technology. And so right now, automation technology already exists. You may have seen cars that have blind spot warning, adaptive cruise control, lane departure warning, lane keeping assist. These are all systems that exist today on commercial vehicles that are meant to improve the safety. And so as we continue to develop this technology, more and more of these so-called driver assistance systems will continue to take over this automation role. And eventually it will get to the point where we can sort of turn around, the driver can turn around in their seat and maybe play a game of checkers instead of focusing on the road. I think that scenario is decades out still. I can imagine slight improvements in automation technology every year, every 2-3 years perhaps, and eventually we'll get to the point where there's so much automation that we don't have to pay attention to the road.
All right, great. You know, it's not maybe so much about the destination as it is about the journey. And thanks to you, you're making that journey even better. Hey, Dr. Asher, thank you so much and best of luck with your research.
Thank you. Yeah, we're going to need it.